Hey everybody, welcome to Unit 1's lesson number 4, Parent Functions and Transformations. This lesson would have been useful for what we were doing at the end of yesterday's lesson, but that's okay. If you remember, yesterday we were graphing absolute value functions, and we had to list out a table of values, and it was kind of a pain, right? It took a little bit of time. So if there were only some way that we could graph by looking at the function as it is, and having some way of knowing what's happening to it. Well, that's what parent functions and transformations are going to do for us. Something that you're going to need for this lesson, obviously, is graph paper. So if you don't have any graph paper, I would try to get some. I think I might put up a link in the documents section of the website, so you might be able to go there and print some out. But you're going to need some graph paper somewhere, so get yourself some while you get the chance. All right, first thing we're going to talk about are things called parent functions. The reason why parent functions are so useful is because it gives us the general shape of a function. We know how the function is going to behave in general based off of its parent function, its most basic. Okay, all linear functions just follow in the same path, right? Like a beam of light, it just goes one way and the other. Versus a quadratic that we know has this parabolic shape to it, right? It gets increasingly larger faster, but it also goes down to a certain point and changes direction, all based off the fact that we have a square in quadratics. And we know from looking at the absolute values yesterday that absolute values actually follow a linear function to a certain point, and then it reflects, because anything that would be negative inside the absolute value will give us a positive version out, so it should be symmetrical. So we have some things that we can look at that we have an idea of what they should generally look like. All quadratics will have a parabolic shape to it. You're not going to get a straight line out of a quadratic. You're never going to get a v function out of a linear, right? So we have a general idea of what they should look like. We also have some pretty interesting points to work with, right? We have the y-intercept, which is really useful for linear functions. But then for these two, we have a vertex, right? I have a vertex 0, 0 for my quadratic, and I also have a vertex 0, 0 for my absolute value functions. Those are going to be really useful because those are the points that we're going to be moving around in our transformations. Before we go any further, I want to point out one more thing. There are specific height patterns for each of these types of functions, for each parent function. For example, with our linear function, my slope here is 1, so I have a spacing of 1 over 1, right? So that's the general spacing for a linear function. That's kind of the same over here for absolute value, right? Up 1 over 1, up 1 over 1. So it has that spacing of 1. But our spacing is dramatically different for quadratics, right? You have to really know how squaring numbers works. If I plug in 0 and square it, I get 0 out. If I plug in 1 and square it, I get 1 out. But if I plug in 2 and square it, I should be getting 4 out. So the spacing between these first two heights and the spacing between the first and second height, that changes. It's not constant, right? This went up by 1, and then it goes up by 3. And if we were to do the next one, 3 squared would be 9. So between 4 and 9, that's a spacing of 5, right? So this spacing is not the same. And we need to keep track of that, because when we start looking at transformation rules, we're going to see that sometimes our spacings and heights will get stretched. So let's take a look at these transformation rules now that we're getting into it. Okay, for any function f of x, we have this possible look to it. This could be linear if we don't have any kind of brackets or anything, right? Something that we saw here. Oh, you can't see that. We could have, if we had a square right here, it could be a quadratic. Maybe if we had a cube, it could be a cubic function. If these were straight lines, these would be absolute value. We could even do a square root radical right here, right? We'll get to those later, but there's all sorts of different types of functions. So right now, these are little parentheses. It's just a function in general, all right? But things that happen to any type of function are going to be similar amongst those functions, right? If I were to have a negative, I know that each of these functions that I saw, you still can't see those, right? If I have a negative, each of these functions are going to flip vertically. That's what happens. It doesn't matter if we're working with linear, quadratic, absolute, any of them, cubics, right? They're always going to do that flip. If we have a d-scalar multiplier on the outside, so if we have a number multiplying on the outside, that is going to affect your height, right? Making these things taller. So here you would see a slope. Here it's going to get larger proportionally throughout. And here again you would see it affect the slope. So if we have a number, it's going to get taller. Right? If that number is a shorter number, it's going to get shorter because it's affecting your height. The negative h value, it says negative in here, but we want to be using the opposite sign, which is specifically why they put a negative. You guys mostly would think of when you see that as negative h. Once you get more and more into your math, you start thinking of this as opposite of h, right? So we want to use the opposite sign. And that's going to be giving you your left-right movement. Okay, so if you see, for example, -5, I'm going to be moving it left and right, but I'm going to move it to the +5 direction, which would be to the right. If you see, let's say, +18, right, I want to use the opposite, so it become -18. So I'd be going to the left 18. Outside the function, whatever is being added, notice how this says +k, right? So we want to keep the sign. So this is going to be our up and down shift, and we follow the sign. There are a few other things that could happen transformation-wise, but you guys, you're in Algebra 2, so I'm not going to stress you with things like horizontal flips and horizontal stretching. We might do a little bit of that later on in the year, but for right now, let's just practice on some of the easier things, and then we'll add some of the more difficult things in later. Okay, let's perfect one thing at a time, or maybe not perfect, but get as good as we can at something while we have the time to, and then we'll add a little bit more later. All right, so we've got two examples here. You might want to draw out some graphs if you need to and write these examples down. I need to identify a couple of things. First of all, the type of function, right? If I'm looking at my parent function, this is a quadratic, so I know the general shape of this should be a parabola. Then I want to look at some other basic things. Movement. I'm going to always do my movement first, and then I'll do reflections after, and then any kind of stretches. Generally, I'm going to work this way, right? So let's take care of some of this stuff. I know I have to do the opposite direction inside, so I want to move -2, and on the outside I want to follow the sign, so I'm going to move -3. Now, what exactly is moving? Everything is moving, but the point that I know best on a quadratic is right here at 0, 0. And I can move all that one point, and the whole rest of it will move with it. That's the general idea. So if I move the vertex, which was at 0, 0, it tells me to move 2 to the left and then down 3. Here at -2, -3 is my vertex. As far as the rest of it, I don't have anything making it taller or shorter multiplying out here, and I don't have any negatives to flip it upside down. So I know, you can't see that still, huh? I know that we keep that parabola shape because it's not being flipped upside down and it's not getting stretched any taller. So what I need to do is I need to add in a few more points. I need at least 5 good points. So here's the idea. Let's look back at this quadratic up here. Remember how before we had the space of 1 over and 1 up? That's going to repeat on both sides. So going back to my graph, 1 over and 1 up on both sides. That's cool. Now I got to think about what the next points would look like. From my vertex, if I went 2 over, well, 2 squared would give me 4 as a result. So from the vertex, I would go 2 over and 4 up. Okay, so from the vertex, I would go 2 over and 4 up. There's a point right there. 2 over and 4 up puts a point right there. So you notice that my spacing did not change from what we saw up here. It's just things moved different directions based on what they gave us. Okay. Last thing, we're just going to draw in the rest of that parabola. Okay. Very similar concept right here. We look at our function. We have an absolute value function this time. So we have a v. That v still has a vertex, right? 0, 0. Pointing at it again, you still can't see it. Right? We have a vertex for our absolute values. So we're going to move that point around, and everything else, which we know what it looks like, right? It's just a diagonal line going through those boxes, right? That should all look the same. Because I don't have any kind of scalar multiplier, and I don't have anything flipping it, so it should still be a v. This tells us to go positive 4 because you go opposite the direction, and this tells us to go up 1 because outside you go with the sign. So I want to take my vertex, which was here, and move it 4 over and 1 up. There's no flipping, and it's not getting any taller or shorter, so it should still be going through the diagonals this way, and then through the diagonals that way. Whoa, I missed those points. Sorry, I missed them a little bit, but do your best, right? That's really like how they work. We're gonna see a couple of other things like the reflections and the stretches and stuff like that. But if you can get at least this stuff done and you move your vertex to the right place, you got like half of the battle won at that point. Okay, let's take a couple look at a couple extra examples. Here we have f of x equals negative x minus 1 squared plus 2. So we have something that's happening that we didn't see before. We have this negative right here. I know that that negative is just going to flip everything upside down. What specific shape would be a parabola? So I know instead of it being a U, it should be an upside down U. I know that I need to move positive 1 or to the right because it's opposite signs, and I need to move up 2 because outside we go with the signs. So I know we have a parabola. I'm going to move that vertex 1 over and 2 up. So my vertex is right here. Now normally our parabola would open up like this, right? But because it's being flipped upside down, when I draw these other points, I have to make sure that it goes downwards. So remember, our parabola goes 1 over, but we want to go down instead of up on both sides of that vertex, right? So 1 over, 1 down. And I need another point. Go back to my vertex. I would be going 2 over and then 4 down. Remember, 2 squared is 4. That's where we're getting our heights from. But because of this negative, it's going down. And then we just draw on the rest. Not that bad, right? We move the vertex, we keep the pattern, we just flipped it upside down. We got an absolute value problem. No reflection this time, but we have a scalar multiplier here, right? It's going to be 2 times taller. Let's worry about that in a second. First of all, I need to move -3 because we move opposite the sign, and then down 4. And because this is absolute value, I know it's a V, and I can move my vertex first. So I'm going to move over 1, 2, 3, and then 1, 2, 3, 4 down. Now, as far as this 2 scalar, it's going to be twice as tall. So if normally I would be going 1 over 1 up, I need to make that up twice as much. So I'm going to go 1 over still, but instead of going 1 up, I'm going to go 2 up because that's twice the height. Now think of this as like your slope, right? Imagine this is 2x, this is 2 over 1, you have a height of 2 and a run of 1, right? So it's still following the same kind of slope idea. We would follow it through this way. But on the other side of your vertex, it's going to still be a V, so it should be the same points, just on the other side. Right? I'm going to put one there, and I'll put one there. There would be another one up here if I could fit it. And then we just connect. Okay. So I've got a couple of problems for you to try right here. These are the last 2, 4. Wow, 4 it looks like. So if you want to try to get them all done at once, that's up to you. I would pause the video, do them all out. I'm going to go over them each right after. So pause and then resume when you're ready to check all 4. Alright, you got all 4 done, I'm hoping. So I'm about to go over all 4 right now. The first 2 are quadratics or parabolas, right? I see a square and I see a square. So I know that we're going to have a U shape. This is definitely U because there's no negative and no negative here, but this is going to get stretched. So we'll keep that in mind. Let's do this one first though, right? One thing at a time. I need to move opposite direction, so I want to move +3 and then with the sign on the outside. So I need to move my vertex over 3 and up 2. That puts my vertex right here. We're not flipping it, so it's still going to open like a U, and we're not stretching it. So the normal pattern of 1 over 1 up and then 2 over 4 up, that still fits here. So here is our parabola. The second one that you had to do, well, we're moving left and down according to those signs. We still have a parabola. It's not going to flip, but it's going to get taller. So let's deal with the movement first. Move it 2 and then down 3. So here's where our vertex is. Now I want everything to be twice the height as what it was before. So if our parabola normally goes 1 over 1 up, I need to double the up part. So I'm going to go 1 over and 2 up. Then if I normally go back and go 2 over 4 up, I need to double the up again. So I need to go from the vertex 2 over, and this time 8 up, putting that point way up here. Now, because this is my vertex, I know it's going to be symmetrical on the other side. So I know I have another point over here, and I have another point over here. Right, so I used half of my parabola to get the other points. And then make sure that this is as rounded as you can get it at the bottom. And there you go. How did you do with those 2? Both of them were parabolas. Neither of them had reflections. One of them had a dilation. It's a technical term for it, if you remember from geometry. You had 2 more to do. This one is probably the toughest one on here, right? You have a right and up movement for your vertex. We're working with an absolute value, so it should be a V. So I'm going to move our vertex right here to 3, 3. But it's going to flip. So instead of going up, it's going to go down. And our height is going to stretch to be twice as tall. So instead of going 1 over 1 up, I would need to go 1 over 1 down, but that down doubles, so it would actually be 1 over 2 down. 1 over 2 down. Back to my vertex, 1 over 2 down, just in the opposite direction. And that's what that particular function looks like. We just need to connect those points. probably the most difficult one on this video. Your last one. We need to move left and up. No flip, no stretch. It's still a V function, so we move 4 over and 2 up would be right there, and then it's just our normal absolute value V function. Okay, so we had a little bit of everything mixed in with those last 4, right? We had the translations moving left and right. Just remember, if you're inside the function, you move opposite the sign left or right. If you're outside the function, you move with the sign up or down. If you have a number multiplying on the outside, it's going to get taller or possibly shorter if you have like a fractional number, like half the height, right? But just remember that affects the height. And then last, if you have that negative on the outside, it's going to flip it vertically. So whatever you would do in the up direction, you instead do in the down direction. Really not that bad. The more you practice these, the better off you'll be. You don't have to go crazy doing, you know, making up your own problems. You can actually redo some of these after like a day and kind of get used to them, even if you're practicing the same ones over. That works. It's worked for me. I bet you it can work for you. Anyways, I'm rambling now. We're at like 21 and a half minutes. I think that's long enough. We'll see you at the next lesson, lesson number 5.